So, okay. So one more time, thank you for joining this session of Ask Alex on how to configure libraries for deck templates, beam, pier abutments, and barrier configurations. Right? As you know, we are using our training guide as a guide, right, to develop these training sessions. And for that, right, we are going to be using this training manual that I send you on the link invitation, right? And include it one more time when I send the thank you note as well. So this is the training guide that I'm using. And today we're going to cover module 7, that is the configuration of the libraries itself. So this is the training guide that I'm going to be referring to, and more or less even going step by step with this, right? So I'm going to put it aside, right? So as doing that, now let's start. So let me take this out. Let's start from 0, right? Let's start with OpenBridge Designer. We'll start that. Right, and then from 0, let's create a new OBDX file that will guide my project to. So let's create it on the Bentley training folder. Let's call it libraries, for example, right? Just to have a name. So I kind of use it on the standalone of the Beam workflow. For this case of this example, it's actually relevant because we're going to be just using the DGN part of it, right? So I will create a new project and then OpenBridge model. So if you're following me on the training manual, it's on page 120. I'm going to create from scratch a new deck template. Right? So saying that, I will just pick what workspace, what the standards I wanted to use. As you can see, I'm working with many different DOTs on that. So, but then I'm going to use the standard one. That's what I'm going to use, the Imperial standards. Right? Just browse for a file that it's on my training guide. On my training guide, it's on the introduction to OpenBridge Modeler, Imperial, it's module 7. We already give you the library file. Actually, this is an empty file, right? That's an empty file for that, right? So let's go for it. Wait until it opens up. And by the way, my colleague Steve Willoughby, it's on the session as well. You have any questions? Oh, the chat is very active. So yes. And yes, on the question, Kamlesh, about the guide, when I send you the email after this session, I will include the link so you can download the training guide and the dataset. Okay, so let's use the Imperial standards. Let's get into that. All right, it's loading all the standards. So it takes a little while, yes, but not that much higher. All right, here we go. So now let's concentrate in general on that configuration. All right. So all the libraries that we use before going into the training guide are right here into utilities. So we got deck libraries, barriers, beams, abutments. So all of that are here. Let's concentrate on what this class is all about, right? So, and as well, these libraries are saved into specific files, right? So, and these files are XML files that you can access them, right? Just to say something here, for example, if I go to Piers, I'm going to access the Pier library, right? You see the name at the bottom here, right? Pier lib. That is where all these piers that I have here, right, are stored into that peerlib.xml. So every file or every structure type, barriers have their XMLs, the materials, the wing walls are XMLs too. But most of them, the bulk of them, are on that file called templates.xml. And this is part of the library that we deliver into every standard. And that's what you may want to transfer to, right? So just look for that file. It's a whole series of libraries addressing all of this. You can get a good list on the configuration list or the configuration file that we provide. All right. So let's go for the example then. So as it says on jumping all the way to step 4, I'm in the utilities tab, and then I'm going to go next. Right. I'm going to define from scratch a brand new deck library. So it opens this dialog box, right? And in that file, templates.xml, we already have the standards here, right? So deck slabs, segmental boxes, a little bit more elaborate if you want to, right? One easy way to start with this configuration, right? It's basically you can just go and say, look, I can right click right here and right click and copy an existing one and modify it as I wish, right? Or I can just well, copy that and I will do it, all right? And edit the geometry after, right? But let's start one from nothing, from zero, right? I mean, you know that you can copy and then you can modify, but then I will just show you how these variables play together on this, right? So I'm going to create in this new folder that you can also create, right? And let's create right here, right click, and I will say, as it shows on step 6 at the bottom of page 120, that I want to add a template, right? And the name shows up to my other screen, sorry, that. And then I go and say, well, let's do this template, call it slab 1, just to say so, right? So that's it, right? So I create a new one and then, oh, something disappears because now it's asking me, well, where are you going to develop that geometry? No? And then if you see at the bottom left, select view for template, what? Template design. Click on any view. So I'm gonna go a data point or a left click right here. And then everything changes, right? The look of the screen changes as well, right? And then this is how we start. Now you recognize the same commands, feed view and all of that. The difference is right here, right? In which you can say, send the information back to the template. So let's develop the template. This is the working point. This comes as default, right? And now, you can start doing this, right? So I would say draw, yes, MicroStation, draw as close as possible the dimensions that you want your deck to be, right? Why? Just to show better on the screen, baby. Right? Because think about it. With variables, I can control the geometry. So put it away. I can create a deck like looks like that, right? And through variables, I can modify it and make it nicer, right? But no. So let's undo work. So now let's do something nice. Okay, so let's create a deck, more or less, with the dimensions that I want, right? So I can just say, well, let's do this, right? More or less, what, 20 feet. So let's do 20 feet, right? And I'm going to concentrate that much on the slope, right? Because again, now the slope, I just can do it with variables, right? Just like that. And when that will do it, right? Because now I can just say, okay, let's do this like that. Thickness, let's do something similar. And here on the deck as well, I can just do it like that. Right? I can do mirror copy and just mirror the other side to make my deck more or less the way I want it, right? I can do that, or I can just keep drawing and then see. Now, I take close attention to this because look, I am providing individual lines to simple lines to the deck itself, right? I'm not using any smart line or anything like that because every vertex will be a point that I can use to modify the element, right? At this point, it doesn't look that much of a, well, it looks like a deck, but maybe not the exact dimensions that I want, right? I could have done a fancier drawing, but just to illustrate the point, this is what we can do, right? Especially in the training manual, it says there's step 9 and 10, I use the mirror and all of that to have a nicer template, but they should do it as well. So now we need to modify the geometry, adjust variables to make this deck, right, fully parametric, right? So then step 11, I'm going to bring it back, lack of a better name, parametrization process, right? So import template from model. Going back, yes, and I am back into the script. So you see the points, P0, P1, P2, P3, P4, P5. Right, so these are labeled by the manual automatically, right? So now also what you can do is either change the names here. So you can go and change the name of P0 of P1 to whatever is relevant to you. Like P1, for example, could be right lane, right? Or RT, right? So we follow the manual, right? And the way I did it, P1 is to the right, right? So it's basically mimicking the manual here, right? So if we follow that, so then we can establish the relationship between every point on that deck, right? P0 is the same as WP, as the working point. So this is where the alignment and profile of the bridge will be applied to. So this will be the center line of the deck, if you want to call it like that. So then here we go. So P1. So what is P1? Right here. Oh, and here too, right? You have options to enlarge this. Well, it's a little larger for the screen. Let's do that. Bring it to my other screen. Here we go. So let me enlarge this a little bit better so you can see it on your screens too. I can do fit view. Better. Okay, now it's way much better. Okay, so here we go. So P1, what is the relationship between one and the rest? So step 13, page 122, I go P1, standing on there, right? And say, well, what is the relationship between P1, right, and P0, or the working point? Well, P1 is defined by the distance from P1, from P0, right, that distance, and also by the slope of the roadway, right? So P1 is controlled by what constraints, and that is the definition that you click here. What it would be better to define for you as a location of P1, right? So I can say P1 is located using a distance, an horizontal distance, right? And as well, and a slope for that, right? So that's how I define that constraint, horizontal and slope, from where? From what point? From the working point for P0, you decide working point P0 is the same. So I will do working point, right? At what distance I want it to be the default, right? Since I draw it kind of freehand, that is the distance that it computed, 19.98. No. I want the horizontal distance as a default that I can later change at 20 feet. And the slope that I eyeball, no, I want it to be, I know, 0.02. Now, testing the slope, right? So we can do this too. Look, nothing changes on P1 until I save. So let's see what happened. See how it adjusted? Let's test it to see if it changes took place. Let's do 15, for example. Save it. Okay, yeah, that's it. So you see how I'm controlling this? Okay, let's do that to it. Right, and then what about if I put a positive slope? From 0 to 1, from 0 to 1, it's going down or it's going up? So let's test it because it's supposed to be normal ground, right? So let's test if I do 0.5, see what happened with that slope. Oh, no. Has to be negative, right? You see? Because it's going down from 0 to 1, it's going down 2%. Much better, see? So that's how I can control the geom. But then this will be a hard-coded value, right? No. I want it to be parametric. So when I define my bridge, maybe it's 20 feet, maybe it's 22, maybe 16, right? So I want to change that. So I'm going to make it into a variable. And how do I make it into a variable? As simple as typing the name of the variable, right? So for example, I'm going to deviate from the manual here, but then to do it, RT width. That's it. That's a variable, right? So that's what I'm making now. Let's comply with the manual. So let's do it nice. RT LN, right? Width. That's it. I got it. And the slope is going to be a variable too, right? So I'm going to call it RT LN and the right slope. So that's the right slope, right? And then to make changes hold, I just hit save. Got it? Sure, but then the question comes, yes, with these variables, I can make it parametric so I can fill up a table and then, do the variations. What about if I have the open roads super elevation file that they give to me? How I incorporate these DGN, super elevation DGN into this? Forgot something. That. When we check this, so then we're going to be able to file reference the super elevation.dgn file coming from roadway, and my deck will move according to that file. Overriding the slope here, it will use the DGN, but only if this is activated. And then I need to activate it on P5 too, but that's what it needs. So that fully defines P1, right, on step 15. And we just save it. Right? Done. Right? So now, what about P2? Right? Step 18. P2, standing on P2, right? What is the relationship between P1 and P2? Well, that's the thickness, right? That's the thickness of the deck. That it could be variable too. So what would be, you think, the constraints that I need to apply to P2? I would say it will be horizontal and vertical from P1. Well, not the working point, P1. And the horizontal distance is 0, right? It's one on top of the other, 0. And there is no need to define a variable for this. Then the vertical distance from P1 is going to be a negative distance, and it's going to be the default thickness that I want to apply. But then I'm going to make it a constraint. I'm going to call it, this is going to be my deck thickness, right? And I just define completely the right side of the bridge. This doesn't need the super elevation flag or anything like that, because everything is constrained by P1. P2 will just follow. Okay. And save it. Done. Right. So what about P3? Oh, P3 is just the same, right? It's the same horizontal and vertical. But now from P0, right? Because it's right at the center. Or the working point, either way. Right? And the horizontal distance will be 0. Right? Let's check. Yeah, it aligns a little bit. Right? And then the variable that it will use, it will be the same distance. Right? And then minus 0.75. That's what I use. So it just does it there. Right? Got it? Now, what about P4 and P5? Well, I will use the same concept. Right? So P4 will be what? Will be the same horizontal and vertical constraint from P5, but the horizontal will be 0, right? Right below that. And the variable that is going to use is deck thickness, and just to be nicer, that is the one default value that I use. So it's P5, right? P4, I'm sorry, P4, based on P5. But P5 now, that is a more elaborate stuff now. One more time, it's controlled by the horizontal and the slope based on P0, right? And it was 15 feet. No, it's negative. It's going to the left, so it's 20, right? So let's say, see how it's moving together now? The slope is wrong, right? But the slope is going from P5 to P0, so it's going up, right? If it's normal ground, so it's going up. So I'm going to go 0.02 as default, but I'm going to use, it could be a different slope. So then I better use the left lane, the slope variable, to take care of that. So let's see. I got my deck, right? And then, well, hey, on step 23, it reminds me that P1 needs to have the super elevation flag, and P5 too, don't forget, right? And then save it, so I have my full deck created already, right? So can you have more elements here? Some people are asking here that, what about the sidewalks? Yeah, you can build in a sidewalk on the deck too, but remember, this will be a deck. It will be part of it. Can Leap handle that? Do you want separate quantities for the sidewalk? So then you cannot do it, because then it will be part of the deck, right? So can I incorporate barriers to this? So, well, you can too, right? But then you will not have a separate quantity for the barrier, and you cannot treat it as such, because it's just part of a single deck element. So just be mindful of that. So just, there's different ways to do this, but then I would say the deck is what it is, your deck, right? So then we are done with that exercise. Just as simple as it could be, right? And then I have my slab 1 or class template. I mentioned that you can change the names of the elements here too, like P1, P2. Yeah, you can go here, right? As you see a name here, P1, and can call it right. Let's call it right lane for it, right? So you can just change the name of your points right here and say, right? And then look, the points change it too, right? And P5, I can just rename it and call it left lane. See? So when your users pick it up, well, they know what they're picking up, right? And you see the screen too. And P2 and P4, I can name it thickness or just leave it as is, right? So they know what we're talking about right there. Now, to display this a little bit better, of course, you have these options, right? That they to increase or decrease the text size, so you can see it better, right? And increase the exaggeration too. So this is basically what we develop, right? And then also show the construction line that we use to create this or not, right? And also the dimensions that you have applied to it, right? So you can just do all of this. And then, well, now you have your deck template that is part now of that templates.xml, wherever it's located, right? So if you need this deck template to be transferred to somebody else, if it's not in the master library that your organization is using, well, you got the option to, right here, export to an XML file, right? Export to an XML file, and then you can pick that, hey, I need to send this slab one, right, to Steve. So save it, and then when Steve gets the file, he's able to import it, right? So you can do all of this right here. So that finishes that deck template. So we hit close, it's already saved, you got it, right? So now when you place your deck, then you will be able to select. Now, on the next exercise, we're talking about barriers, right? That's it. Okay, good. We are talking about barriers, right? So let's cheat. On the barriers, the definition is almost the same as a deck, actually with less variables, right? So let's pick one of the DOT ones right here. Let's cheat, as I said, because I'm not going to draw that barrier. Let's use this one. Yeah, right here, right? And then I just gonna copy it. So I'm just gonna copy that barrier and just rename it, just to illustrate the special variable we have. So I'm gonna rename it. I'm gonna call it class, right? I'm going to here edit the geom just to explain something. So one more time. Oh, where it went? Select view for template design. So anywhere, left click, and it switches. Right? So this is the barrier. You have to create two templates per barrier, one facing the left, the other one facing the right. So that's why we have two set of templates for that, right? Now the working point in this case for the DOT is right at the edge of the barrier, right? But then also that same, some of you or some of DOTs as well, they say, no, 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 our barrier is not placed, at this case, it will be placed at the edge of the deck. It's placed based on this line. So basically it will be a matter to take in this and maybe move it a little bit to comply with that, right? So that will be my new barrier, you know, using the proper distances, of course, right? So you can do that. So, and then you just draw the barrier as you need to, you know, using the commands chamfer and fillets and all of that. So it will be nice, right? And then when you finish drafting this, you will go back to the template. So we send it back, right? Import template from them. Yes, import the geometry. By the way, that any template needs to be drafted properly, meaning no overlaps, no hanging lines or anything like that. You have to have a properly drawn template. We know better by this time, right? So we're back. Right, the only thing I want to mention here, this is what is special on the barriers, is that if you think about it, right, the barrier itself, all this geometry is fine. The problem is at the bottom, right? At the bottom, the barrier is not, it's flat, but remember, it accommodates to the slope of the deck, whatever the slope is, right? So this point could be the edge of the deck, but then this point, P2, this case, is whatever the deck is doing, right? So it needs to accommodate to the slope of the deck. And that's why we have a special variable called elevation provider. So whatever you put it on top is going, that P2 is going to take the elevation at that point and accommodate with P1, right? So in P2, right, at the other base, or the other point of the base of the barrier, you need to say that it's based on the elevation provider. That's one more variable. You didn't see that on the deck. And horizontal, well, that's the distance. Elevation provider is that, right? Adjust to the slope of the deck in this case. So if the deck is this way, P2 will be snapped here. If the deck is that way, well, the slope of the bottom of the barrier will just be a little bit different, right? So that is the point that I want to illustrate when you do the template definition, the variables. You draft it as it was flat, but then the constraint is right here as elevation provider, right? And then when you save it, again, you can just import or export if you need to create it in another project, for example, right? So, and that is what it talks about on page 126. You need to draft 3 different cells, right? Median barrier and all of that. On median barrier, for example, you're going to have 2 points, right? So the working point will be right here, but this point at this point will be maybe with elevation provider variables. Your barrier could be this, unless you want to place it like that, right? But here too, this will be elevation provider here, constraint, and here too, right? So that is the point that it makes when it does elevation provider. Right? Yeah, again, I mean, there is one question, Steve. Yeah, oh, you're answering. Very good, Steve. Thank you for specifying that regarding the to hold the gutter line. Right? So again, but the working point, as Steve is mentioning, right? So is that that working point could be, as I said, a little bit even outside of the barrier if you're going to be, depending on where you're going to compute the elevations to or how you want to snap it, right? As he's mentioning about to hold the gutter line if you have something like that, right? And that's the barrier, fine? Okay, we're good on that. So now let's go to, that finishes this, right? So now what about the piers and abutments, right? That is a little bit more simpler, right? Because on piers, right? If we go on page 130, we can go to piers here. And as I said, these piers are now saved into this XML file, right? We don't need to draw the piers. We just can, from here, we just are basically going to copy and edit what we need. It's easier than creating this from scratch. The only caveat that you have to see is that first, what type of pier you're going to do. It's going to be a multi-column like that, right, with every variation, or is going to be a pile bend like that, right? If you create one here, says, oh, well, that should be a multi-column one, you cannot transfer it here, right? If you import it the same, it's not doable. Unless is the proper major category, I would say, multi-column specification or pile bend specification, right? So make sure what type you're going to do before saying, oops, the wrong one, okay? So just make sure on that. All right. So like, for example, Let's go into the defaults, and I created so many of them. So let's see. First, the recommendation will be just pick the one that accommodates as closer to you want it to be, right? So maybe this is good, or that one, right? So, or this one too, right? So you say, okay, this is closer. I'm gonna need a 2-column pier with this. Okay, so let's do this. So then what you can do is copy that and just call it, well, see column step 4, class pier 1, right? And that is the one that you're gonna be messing up with. So class pier 1, and then you go edit. And then here, be my guest on changing anything you want, right? Now, if you're planning to send this to Leap, for example, so then how you want to be to want it to be analyzed, right? That is on the analytical consideration. That could be changed anytime, but then you know that Leap will be taking care of that as a multi-column, as a hammerhead, or a one, right? So it's up to you, especially if you're doing a single peer. Sometimes a single peer is a single peer or analyzed as a hammerhead peer, right? And then just say, well, playing with these options right here, you say how you want your cap, right? It's going to be taper, it's going to be inverted T, right? There is also a variable cap. Now, this is going to be part of another training session, and we're going to do with the new enhancements that are coming, full column and cap definition with all variables, right? But then as simple as it could be is just change the information, right? So, I mean, maybe this is 40 feet, done, right? Cap height, 36, good thing, right? So you can change the dimensions here and you see the results immediately. You don't need to do save or anything like that as we did with the uh, with the with the text, right? So now also remember that these are default values, but then when you place it, as you saw in previous examples, the cap length could change, right? Because we can say, oh, I just did the length of the cap based on the deck width, right? So it will adjust automatically if you want to, right? One thing also to mention is the working point of this is at the center of the abutment. Excuse me, at the center of the pier, right? Or the abutment too, right? So this is where we're going to compute, for example, the pier station, right? It will be right here at the center. Okay, so we can keep going with this. Now, what is a cheek wall? Well, a cheek wall, if we add it, is that little walls, right? In some states, they use it for protection. So you can define the dimensions here. We use it in Florida as well, right? So you can use that and on the right and also on the left side, the right side. See, you can just add the dimensions and play with this, right? So see 36 inches, right? Like that, right? That's part of the cheek wall definition here. Right? I'm deviating from the manual a little bit, just pressing on time here. And columns, same thing here, right? So it could be a circular column. It could be, one could be circular, the other one could be rectangular, up to you, right? The spacing could be controlled automatically with a certain margins, or you can just say, okay, no, I want to control it myself. So that spacing, you can just basically control it, right? So, right, that is not that good, right? So you can just control it too and say maybe 24 inches, see what happens. See? Or it's better to do auto spacing automatically, right? If you need to add another column, well, there's another column, right? With the auto spacing option with different depths or no, right? So you can control these automatic or manually too, right? Now the footings are too close together. I know that you can change the dimensions and all of that, but then you can say, you know what, I need to be this better a combined footing. with new dimensions. Okay. But then as I change it, my piles got messed up. So I go to piles, right? And I said, well, I want H piles, rectangular piles, circular piles, right? With a certain diameter. But then these 4 piles don't do it. So I can go to my pattern layout. And on the pattern layout, I will be presented with the options here. And just say, well, I need 2 rows, but then I need more columns. So I need 5 columns per row and generate the piles. And that will be the new piles. And the question sometimes was asked, well, what about the margins? Well, the margins are measured from the center of the piles, right? So that 30 inches that you see here is just that, right? And they are all vertical piles. Now you want to battered positions? Well, you can activate these options right here and maybe batter the positions of each one of the piles if you want. And if you have a special requirement, right? So then you can just activate and move one of the piles if you need to. So let's see if I can move here too and see how it moves. So just move that one pile and make it part of my library, for example, if I need to do it, utility conflict, for example. Hit OK. And now I have a full set of piles ready to be placed. Save it. And now you have a new configuration for your peers. Now, just to finish, well, it's beams. Beams, it doesn't have that much science, guys, right? So the beams is the same option. You go beams here. Even though we provide you a lot of the beams for many different DOTs, and you can request from your DOT the library as well, right? There is no variables that are defined here, as you can see. It's just a matter of drafting the geometry at, of course, one-to-one scale, the real numbers, and just save it. There is no variables to define or anything like that. It's just a set geometric shape, right? So just that to be in mind. So there is no much science here. It's just draft it with the proper dimensions. You're good. Don't worry about the number or the name of the points or the, because you are not going to use it, right? So it's just a direct definition. So on the beams is not that much science, and they are safe, as you can see on that templates.xml file. So the piers, the barriers, the decks, columns are saved into that XML file that you can just transfer, import individual elements, or copy to that was. Right? So, and that's all I have. So you have any questions? I'll be happy to answer that for the few minutes that we have. One more time, send me an email if you just want to see a different topic, a specific topic. We can cover that in the next session, right? I'm going to be sending you the invitations next week, so hurry up with your comments. By this time, I'm going to stop the recording, all right, and then answer your questions.